In this video, I'm going to talk about Henry's law. Henry's law states that the solubility of a gas in a liquid is directly proportional. This symbol means directly proportional to the partial pressure of the gas above the liquid. A good way to understand Henry's law is to just think of carbonated soft drinks. So, like a bottle of Pepsi. So, before you open the can or bottle, the gas that is above the liquid inside the bottle is carbon dioxide with pretty much no other gas. So the pressure is higher than atmospheric pressure. And the liquid also has carbon dioxide inside it dissolved. So when you open the bottle, the gas will escape, giving you that characteristic noise you make when you open a bottle. Pretty much any bottle that is carbonated. And in some cases you will see some bubbles rise, and that's because the partial pressure of the CO2 above the liquid, so the gas above the liquid, has lowered, and therefore the solubility has lowered too. And that's how Henry's law works. So this is a formula. The solubility of the gas is S gas. The Kh is the Henry's law constant, and P gas is just the pressure of the gas. So the solubility of the gas is going to be equal to Henry's law constant times the pressure of the gas. And an alternate form of Henry's law is stated by this formula, and that is used to predict how the changes in pressure affect solubility. And also one problem, Henry's law problems are pretty simple. So we have our Pepsi bottle here, and let's say that the partial pressure of CO2 in the Pepsi bottle is 3 atmosphere, 380 at 25 Celsius. So I forgot to mention Henry's law constant, so our Kh, is specific to a gas-solvent combination at a given temperature. So that's why I gave you this temperature. In this case, our constant is 0.033 moles over liter atmosphere. And there are two questions. What is the solubility of our carbon dioxide in the bottle under the 3 atmosphere? And the second question is, what is the solubility of the dissolved CO2 when the bottle is opened, if the partial pressure of the CO2 in dry air is 0.0003 atmosphere. So this is our CO2 dry air, or we could just name it P2. So let's do number 1 first. Those are the equations. We wanted to find what the solubility of the gas was if the constant was 0.033 mole liter atmosphere times a pressure of 3 atmosphere. So solubility is 0.099 moles per liter, or you could just write it as molar. So this is the answer to the first question. And then question 2 asks for the solubility of the CO2, the dissolved CO2 when the bottle is open. So now we had to consider the pressure of dry air. So we can use our second equation, the alternate form, and arrange it to find what S2 is. So S2 is going to be S1 times P2 over P1, and we can just plug in the information we have. Our P1 is the pressure of the gas before, so it's 3 atmosphere. This is P1 and this is P2. So, and we just found what S1 was, so 0.099 molar. Let me erase these arrows to not confuse you. That's going to be times P2, which is 0.0003 atmosphere, over our P1, so 0.033, no, 2 atmosphere, sorry, put the wrong value, 2 atmosphere. This will cancel this, and the result will be molar, and we get that S2 is about 9.9 times 10 to the negative 6 molar. So you pretty much have to only worry about these 2 equations for any Henry's law problems. If you found the video helpful, like it and share with your friends.